Is there a formerly obscure planet hidden in the farthest reaches of the nearby planetary system? An increasing number of astronomers now believe that the mysterious Planet 9 is real. And mind you, this is not a dubious guess but a solid conclusion. The strange anomalies in the Kuiper belt literally scream that a massive celestial body is lurking here. But that's not all. A team of researchers is now even confident that an unseen planet must be lurking at the edge of our home system. But what led the experts to this thrilling suspicion? Why has Planet 9 still not been officially confirmed? And why is it so difficult to find it? Have you ever wondered where comes actually come from? Well, if so, then you have something in common with the Dutch astronomer Jan Hendrik Oort. Dissatisfied with the idea that the source of comets is somewhere out there, he hypothesized a spherical zone at the edge of the solar system in 1950. This zone, known as the Oort cloud, acts as a natural reservoir for comet nuclei. Unfortunately, the Kuiper belt is a ring-shaped structure of icy debris, located just beyond the orbits of Neptune and Pluto. In addition to comets, it contains icy chunks and small planets. But beyond that, and this is the astonishing part, the Kuiper belt has. But what is this intriguing? Well, it's not as unreasonable as it might seem. The planetary mystery would be located far beyond the orbits of Neptune and Pluto, making it so distant from us that it remains seemingly invisible, even to the most powerful telescopes of our time. Fortunately, direct observation isn't the only tool at the disposal of experts in their search for a planet. If there's anyone who knows how to crack the enigma of the Kuiper belt, it's Michael Brown. The American astronomer has been dedicating himself to uncovering the icy worlds at the edge of our solar system for quite some time now. He named the largest of these worlds Eris, although he might as well have called it Pluto Killer. In fact, the discovery of the dwarf planet contributed significantly to Pluto being removed from the list of official planets in 2006. While Pluto's demotion still stirs controversy in some circles this day, Brown reflects on his landmark discovery with a mix of humor and pride. On social media, he even calls himself the Pluto Killer. On the trail of Planet 9, 2006 wasn't just the year of Pluto's farewell. It was also the year the discovery of the so-called distant detached objects shifted astronomical paradigms. The objects, also found by Brown, formed the foundation of a research study that led to a groundbreaking conclusion. A completely unknown planet might truly be hiding in the far-off realms of the Kuiper belt. In detail, the self-proclaimed Pluto Killer, along with his colleague Konstantin Batygin, investigated the mystery of the peculiar orbits of these strange objects. Follow-up studies showed that 6 of them follow elliptical orbits pointing in the same direction. A puzzling finding given that the objects move at different speeds, and their orbits are of varying sizes. Even more perplexing, the orbital inclinations showed a consistent tilt of about 30 degrees from the plane of the other planets and objects in the solar system. Could this really just be an extraordinary coincidence? Brown answered this question with a firm no from the outset, even estimating the probability of such a coincidence at just 0.7%. Initially, astronomers didn't suspect Planet 9 to be responsible. Instead, they proposed that the gravitational influence of several large objects, such as a cluster. Thus, the mystery had to be solved from another angle. After several simulations, Brown and Batygin reached the striking conclusion that all the observed anomalies could be explained by the presence of a planet about the size of Neptune. For this to be the case, its orbit would need to be positioned 180 degrees from those of the other planets and Kuiper belt objects. Indeed, the astronomer duo soon realized that more and more observations aligned with the presence of such a Planet 9. For instance, the unusual orbits of the trans-Neptunian object Sedna and another large celestial body, without gaps, could be explained. But does this truly settle the matter? Why haven't we found Planet 9 yet? However, according to the specialists' models, Planet 9 weighs somewhere between 9 and 10 Earth masses and orbits the Sun at a distance of 400 to 1,500 astronomical units. To put this in context, 1 astronomical unit corresponds to the mean distance between the Sun and the Earth, which is around 150 million kilometers. While our natural home Earth requires 365 days to orbit the Sun, Planet 9 takes approximately 20,000 years, if it truly exists. The puzzling planet is thus out of reach of our ordinary telescopes most of the time. Furthermore, there is the fact that Planet 9 is likely very faint. In this regard, the model calculations by a team from the University of Bern have shown that its characteristic glow is only 0.06 that of Neptune, which itself has a value of 0.01. Furthermore, the faint radiation from Planet 9 is likely primarily in the infrared range. This suggests that its temperature would be around 47 Kelvin, minus 226 degrees Celsius, making it only slightly warmer than its vast surroundings. Do these factors imply that we will never be able to confirm the presence of Planet 9 beyond question? Not necessarily. If the celestial body is currently closest to its closest point to the Sun, it may have already appeared undetected in the images of past sky surveys. Even if Planet 9 is very distant from the Sun, hope is not entirely lost, as the planetary bullseye could potentially be hit with the help of a powerful telescope, such as the Vera C. Rubin Observatory. However, a little patience is still required, as the reflecting telescope is currently under construction and will not be operational until March 2025 at the earliest. The full truth also includes the fact that the final confirmation of this celestial body would not only expand the list of planets in the solar system, but also add to the mysteries of planetary science. Why is the existence of Planet 9 so elusive? According to the prevailing view, giant planets form where the primordial gas and dust cloud provides sufficient material. This is not surprising because only in such regions are reservoirs large enough to gradually form larger clusters, and eventually, entire planets. However, with Planet 9, the matter becomes complicated at precisely this point. With an average distance of around 700 astronomical units from the Sun, it moves far outside the zone, where the primordial cloud provided sufficient material for the formation of giant planets. This raises the question of how a planet only slightly smaller than Neptune could end up in such a remote and eccentric orbit. In fact, this scenario challenges our current models of planetary formation to their limits. The same applies to the notion that, according to one simulation, Planet 9 must also be composed similarly to Neptune. This is the essence of the matter. How could a celestial body develop an outer layer of ice along with a thick gas envelope of helium and hydrogen if it spent so little time in the gas-rich heart of the primordial cloud? If Planet 9 does exist, it must have formed somehow. To explain its formation, scientists point to three different hypotheses. In situ formation, Planet 9 initially formed in place in a conventional, nearly circular orbit within the planetesimal disk. The passage of a nearby star then caused it to be gravitationally displaced and brought into its current eccentric orbit. However, the plausibility of this scenario is questionable, as the original cloud of the Sun would have needed to be significantly larger and more enduring than currently believed. Furthermore, there is the question of whether Planet 9 wouldn't have been ejected entirely from the solar system during this stellar encounter. Captured planet. According to this model, the star cluster to which our Sun once belonged was disrupted by galactic tidal forces. Before the Sun said farewell to its stellar family, it may have captured Planet 9 from one of its siblings, essentially stealing it with its gravity. However, the likelihood of capturing a planet is estimated to be just 1%. Ejection hypothesis. The most promising hypothesis currently suggests that Planet 9 formed in the inner regions of the primordial cloud, just like Jupiter, Saturn, Uranus, and Neptune. Gravitational interactions and turbulence eventually pushed the giant planets into much farther orbits. As the outermost member, Planet 9 was pushed the furthest and eventually flung into an eccentric orbit. Importantly, Planet 9 would likely have been ejected entirely from the solar system, unless it was slowed down by the dense gas of the primordial cloud or the passage of a nearby star. Indeed, the discovery of an exoplanet in an equivalently extreme orbit around its binary star system has shown that this is entirely possible. Despite all the possible models, Planet 9 has so far not progressed beyond the status of a purely hypothetical planet. However, who knows? Perhaps the James Webb Space Telescope will soon shed more light on the planetary mysteries of our solar system. And we'd be thrilled if you could take a moment to subscribe to our channel. Go ahead, click the like button, and never miss another video from us again.